Oh man, an irregularity was found in the signal coming from a recently discovered pulsar by 3 separate groups of researchers working at separate research facilities. Is it any signal from aliens, or are we on the way to finding our new home? What's going on in space, friends? It seems thrilling and terrible simultaneously. Hey folks, welcome back to the future space. In today's video, we would try to find out the secret of an unknown signal, from where it is coming or what it is indicating. So without any delay, let's try to figure it out, but before that, hit the bell icon and subscribe to our channel. Actually, after analyzing that signal, it came to know that it is a planet. Just not only a planet, scientists are claiming that it is the oldest planet ever, and the Hubble Space Telescope at NASA was able to get an accurate measurement of the planet's mass. Hence, this planet is the oldest known planet in the Milky Way galaxy. Before Hubble's measurement, astronomers were divided as to whether or not this particular object had a specific identification, brown dwarf or a planet. That was the question. According to the findings of Hubble's investigation, the object has a mass that is 2.5 times that of Jupiter, indicating that it is really a planet. The planet is more than twice as ancient as Earth, which has only 4.5 billion years under its belt, with an estimated age of 13 billion years. Its age is comparable to that of other planets. It did so around a young star similar to our Sun, and it did so only a billion years or so after the Big Bang gave birth to our universe. The fact that the old planet is located in an unusual and dangerous area has contributed to its extraordinary history. It is located in the dense core of a stellar cluster that contains more than 100,000 other stars, and it has an unusual orbit around a pair of dead stars. These latest results from Hubble put an end to a decade's worth of discussion and argument regarding the nature of this ancient world. The simple fact that it exists gives compelling evidence that the earliest planets formed quickly, within a billion years after the Big Bang. This has led scientists to the conclusion that planets may be quite common in our galaxy. A planet the size of Jupiter evolved around a star that was similar to our own Sun eons before our solar and planet ever existed. In the present day, after 13 billion years have passed, the Hubble Space Telescope at NASA has successfully determined the exact mass of the most distant and oldest known planet. The ancient planet has had a fascinating past due to the fact that it has found itself in an improbable and dangerous vicinity. It is located in the dense center of a globular star cluster, where it maintains an unusual orbit around a unique pair of dead stars. The mass of the planet is equivalent to that of Jupiter multiplied by 2.5. Astronomers have come to the conclusion that there may be a lot of planets in the universe, since their sheer existence offers enticing evidence that the initial planets were produced quickly, within a billion years after the Big Bang. The planet is now positioned in the center of an old globular star cluster known as M4, which can be found 5,600 light-years distant in the summer constellation Scorpius. Because globular clusters originated at such an early stage in the history of the cosmos, they lack the heavier elements that had not yet been produced in sufficient quantities in the nuclear furnaces of stars at the time of their formation. Because of this, there is a school of thought among astronomers that globular clusters cannot house planets. This conclusion was strengthened in 1999 when the Hubble Space Telescope came up empty in its search for close-orbiting, hot Jupiter-type planets circling the stars that make up the globular cluster 47 Tucanae. It appears that scientists were merely looking in the wrong spot all along, and that gas giant planets circling at larger distances from their stars might be commonplace among globular clusters of stars. Our measurement with Hubble provides intriguing evidence that the mechanisms involved in planet formation are quite resilient and efficient when it comes to making use of a relatively limited quantity of heavier components. This suggests that the creation of planets took place very early on in the history of the cosmos. Stein Sigurdsson, a professor at Pennsylvania State University, made this statement. According to Harvey Richer of the University of British Columbia, this is enormously promising that planets are probably numerous in globular star clusters. He comes to this conclusion based on the discovery of a planet in such an improbable location as orbiting 2 captured stars, a helium white dwarf and a rapidly spinning neutron star, close to the crowded core of a globular cluster, which is an area where fragile planetary systems have a tendency to be ripped apart due to gravitational interactions with neighboring stars. The pulsar that would later be designated as PSR B1620-26 was found in M4 in 1988, and this marked the beginning of the search for this planet. It is a neutron star that spins slightly less than 100 times per second and emits regular radio pulses in the manner of a lighthouse beam. As a result of the white dwarf's influence on the pulsar, which behaved like a clock and orbited both of the other stars twice yearly, the dwarf was discovered rather rapidly. After some time had passed, scientists saw further abnormalities in the pulsar. These anomalies suggested that a third object was circling the two others. This newly discovered object was at first thought to be a planet. However, it is also possible that it is a brown dwarf or a low-mass star. Throughout the 1990s, discussions on its actual identity lingered. By finally estimating the planet's real mass using some creative celestial detective work, Sigurdsson, Richer, and the other investigators were able to put an end to the argument that had been going on. They had excellent data collected by Hubble in the middle of the 1990s for the study of white dwarfs in M4. Using these data as a guide, scientists were able to locate the white dwarf that was circling the pulsar and determine its color as well as its temperature. The mass of the white dwarf was determined by astronomers through the utilization of evolutionary models that were computed by Brad Hansen of the University of California, Los Angeles. Using this information in conjunction with the amount of wobble in the pulsar signal, the scientists were able to determine the angle at which the white dwarf's orbit is tilted when seen from Earth. This essential piece of data, when paired with the radio studies of the wobbling pulsar, revealed the inclination of the planet's orbit, which allowed scientists to finally determine the exact mass of the object. The object in question has a mass that is only equivalent to 2.5 Jupiter, which means that it cannot be a star or a brown dwarf. Instead, it must be a planet. The journey that the world has taken over the past 13 billion years has not been an easy one. When it was first formed, it most likely began its first orbit around a yellow sun at a distance somewhat comparable to the one that separates Jupiter from our star. The infant globular cluster must have been destroyed in its early days by a violent firestorm of starbirth. The planet survived the searing ultraviolet radiation, supernova radiation, and shock waves that must have been present at the time. Around the same time as multicellular life began to emerge on Earth, the planet and star were descending further and deeper into the core of M4. In this highly populated region, the planet and its sun came extremely near to an old pulsar that had its own star partner. This pulsar had been produced in a supernova when the cluster was still relatively young. There is a good chance that the planet in question is a gas giant and does not have a solid surface as Earth does. Due to the fact that it was created at such an early stage in the evolution of the universe, it most likely does not contain significant quantities of components like carbon and oxygen. Because of all these factors, the possibility of life existing on the planet is extremely remote. Even if life did originate on something like a solid moon circling the planet, for example, there is a good chance that it would not have been able to survive the powerful X-ray burst that would have accompanied the spin-up of the pulsar. Unfortunately, it is extremely doubtful that any civilization was around to witness and document the eventful history of this planet, which began so close to the beginning of time itself. And that brings us to the end of the video. Feel free to let us know what you think about this video. And if you like this video, then please leave a like and subscribe to our channel for all things. Thanks for watching, and we'll see you in the next one.